Okay, finishing up lesson 19 on writing, evaluating, and finding equivalent expressions with rational numbers. So let's kind of put some of the stuff we did in the last video into play. So it says a family of 6 went to the movies. At the concession stand, every family member ordered a drink, popcorn, 2 ordered pizza, and 3 people ordered candy. And part A wants us to write an expression, so no equal sign, that can be used to figure out the cost of the bill. Well, family of 6, every family member ordered a drink. I want to represent that with a D, a popcorn, use a P, 2 ordered pizza, can't use P again, so I'll use Z, because why not, and candy, C. So 6 people, every family member ordered a drink. So 6 people ordered a drink. 6 people ordered popcorn. Okay, so I should say this doesn't represent the number of drinks, it represents the cost of a drink because we're trying to figure out the cost of bill. This is the cost of popcorn. All right, now 2 ordered pizza, so that's 2 times Z, and 3 people ordered candy. That's 3 times whatever the candy costs. So if I want to figure out the total cost, whatever the drinks cost, whatever the popcorn costs, whatever the pizza costs, and whatever the candy costs, I have to add them all together. Okay? There it is. There's an expression that represents the total cost of the bill. Now, it says write an equivalent expression that could also be used to figure out the cost of the bill. Okay, so just kind of stick with me on this one. I want to show you something. So I want to write something that is equivalent to this. Okay, so what if I focused right here on what every family member purchased? They all purchased drinks and they all purchased pizza. What if I just think about factoring this, kind of like we've done in our power standards, right? And I want to factor the 6 out of this and the 6 out of here. Okay, so kind of ignore everything over here. Just stick with me, like I said, for a second. If I pull a 6 out of here and I'm going to put it out front, that leaves me with just 1D. Plus, I'm pulling the 6 out of here. 6 divided by 6 is 1P. So it's kind of like in lesson 18, instead of thinking of it as 6 people buying drinks and 6 people buying popcorn, I could think of it as every person got a drink and popcorn and 6 people did that. And then I can just kind of keep this 2 pizzas and 3 candies floating around. No, I don't want to put an equal sign here because I don't want you to think you have to put equal signs yet. Remember, this is an equivalent expression, and it's equivalent because if I use the distributive property, this would be 6 times D plus 6 times P plus 2Z plus 3C. Okay, so if you were given this and said, hey, is this the same thing? You could use your distributive property and say, yeah, it is. Okay, so this right here is an equivalent expression. Okay, now we can use either one to figure out the cost. So let's say I started with 6D plus 6P plus 2Z plus 3C. Okay? What would be the cost of the bill if the drink costs 5? So D equals 5. Popcorn costs 11. P equals 11. Pizza costs $7.50. Z equals $7.50. And candy cost $3.75. So C equals $3.75. Now, as before, we're just going to substitute all those values in for the variables. So this becomes 6 times 5 plus 6 times P, which is $11, plus 2 times the cost of pizza, which is $7.50, plus 3 times the cost of candy, which is $3.75. 6 times 5 is 30, plus 6 times 11, which is 66, plus 2 times $7.50, which is 15, plus 3 times $3.75, try that again, is $11.25. And I will tell you then, if you grab a calculator and add all of this up, it comes out to be $122.25, which I'd like to say is really expensive, but, oh, it is. It's pretty expensive to go to a movie, unfortunately. All right, I'm going to just show you real quick. What if we tried this other one? What if I did 6 times D plus P in parentheses plus 2Z plus 3C? So I'd get 6 times, and then parentheses, it would be 5 plus 11 plus 2 times the cost of pizza, which is $7.50, plus 3 times the cost of candy, which is $3.75. Order of operations, this becomes 6 times. 6 plus 11 is 16. And then I'm just going to write the rest of this down. And then you just figure things out. 6 times 16 is 96. 2 times 750 is still $15. 3 times 375 is still $11.25. Okay. And then we're just going to add it all up. 96 plus 15 plus 11.25. 122.25. And it's the same thing. Okay? Just like, shouldn't surprise us, is what we've been practicing. Okay? So now here's the new part. Remember how we were just working on that 20% off? Okay? So we know the total price is $122.25. If I wanted to know, hey, I got a 20% coupon off, what's the total cost of the meal? Sorry, not the meal. The movies. Well, think of it as the original, $122.25, minus 20% off. So remember how we find 20% off? We take the original price times the 20%, or 20 per 100, remember? So this would be $122.25 minus $24.45. And if you subtract those two things, it works out to be $97.80. Okay, so does that work if we do it, instead of thinking of it as subtracting the discount, but we think of it as paying 80%, which remember is 0.80? Well, let's try it. Our total bill was $122.25, and I want to multiply that by 80. No, by 0.80, by 80%. And guess what? We still get $97.80. So you get it the same way. This is just a little bit quicker because you're only doing one calculation. Okay? So again, the ability to manipulate expressions, to write equivalent expressions, really pays off later as we're trying to do other things with the expressions. And having a good understanding of the relationship between this is 100% of the cost, we're getting a discount of 20%, or we're, what does that mean, what we're paying? That's going to come in handy later on as well.